Hi, so in this video we're going to learn to balance chemical reactions. The idea of balancing chemical reactions is to make sure that the chemical reaction follows the law of conservation of mass. We can see that in this reaction written right now, that there's only one sodium on the reactant side, and there's two sodiums on the product side, so it's not balanced. Well, to balance this, what we're going to do is we are going to take and we're going to write for ourselves a chart, just to keep track of each element on each side. So I like to write a chart underneath the arrow, and in that chart, I'm going to write each element. So I'm going to write sodium, hydrogen, carbon, and oxygen, because those are the elements that are in this chemical reaction. I'm going to then count how many I have of each element on each side in the chart. So on the reactant side, I have one sodium, one hydrogen, one carbon, 3 oxygens. On the product side, I have 2 sodiums, 2 hydrogens, 1 carbon, and you should pause the video right now and count how many oxygen atoms there are. There are, on the right side, on the product side, 4 oxygen atoms. There's 1 oxygen atom here, plus 2 oxygen atoms here, plus another oxygen atom here. So 1 plus 2 plus 1 is 4. Okay, so now looking at the chart, we can see that the sodiums are not balanced, the hydrogen is not balanced, the carbon is balanced, and the oxygen is not balanced. I can balance any of them by changing the coefficient. This is changing the number of molecules of whatever's behind it. So, for example, I can see that sodium is not balanced. So what I'm going to do is I'm going to say, okay, let's put 2 sodium molecules on this side. But when I do that, that's going to change the number of atoms of everything that's on that side. So that's going to change the number of sodium atoms to 2, the number of hydrogen atoms to 2, carbon atoms to 2, and oxygen atoms to 6, because 2 times 3 is equal to 6. Okay? Don't be afraid to change things as you need to. So now, looking at this, that took care of my sodium, my hydrogen, and my carbon, but my I take that back. If you look at carbon, it is now not balanced. It was, and that's okay. My oxygen is balanced, or not balanced, and it needs to be balanced. So to balance I'm going to go to the easiest thing, which is, in this case, carbon. So I'm going to put a coefficient of 2 in front of carbon, which changes carbon and oxygen. That makes my carbons 2, the whole reason I did that. And then again, pause the video and count how many oxygens there are. You should hopefully see that there are now 6 oxygens, which makes this chemical reaction now balanced. So remember, when you're balancing a chemical reaction, you can only change the coefficient. That's the number in front of the molecules. You're changing the number of molecules, you're not changing the formula of the molecules. Then, whenever you change the coefficient, make sure you recount everything that changes, but only what that changes. So when I change the 2 in this NaHCO3, all of the things change. But when I change the 2 for the carbon dioxide, it only changed the amount of carbons and oxygens. A common mistake students will do is when they say 2 here, they want to say, oh, I only added 2 oxygens, or I added 4 oxygens, or something like that, and then they try and add that number to what's already there. That gets really confusing. Don't do that. That's going to cause you problems. Just stop, cross off the oxygen, and completely recount them. You'll do better. If you struggle with this, you probably miscounted something. That's usually what happens. Good luck. Let's try a second one. For this one, you really should try to do more on your own, pausing the video more often, and checking your answer. So first, pause the video, and then make your chart. If you didn't get the same numbers I got on each side, stop and recount and see if you can figure out how to get those numbers before you move on. Next, balance one thing at a time. Find the easiest thing to balance. I'm going to choose to balance carbon first, just because that's what I see myself. When balancing carbon, I see that I need to have 3 carbons on each side. So in this case, I'm going to put a 3 in front of carbon dioxide, because 3 times 1 gives me 3. But that also changes my oxygen, so I'm going to cross off my oxygen and recount. I have 3 times 2 gives me 6 oxygens, plus 1 that's already there gives me 7 oxygens. Next, I'm going to balance hydrogen. So try to balance the hydrogens and see if you do come up with the same thing I did. I'm going to pause the video and show this quickly. So when I balance the hydrogen, I change the coefficient in front of water to 4, because that gives me 8 hydrogens. I crossed off the oxygen, recounted my oxygens, and I got 10. Again, double check that you're doing that on your own. If you're not getting 10, you're going to cause yourself problems later on. That is one of the most common mistakes that students make, is they don't add up correctly. Now you can finish it off. Finishing it off is super easy. All you need to do is change oxygen to 5, because 5 times 2 gives you 10. That doesn't change anything else. I can see that the whole equation is now balanced. Equations. Here, for the second example, we're going to balance C3H8 plus O2 to find out what water and carbon dioxide are. I'll be going through this much more quickly. You should be pausing the video before each step to try it on your own. So first, make your chart and count your atoms on each side. Pause the video and the answer will show up in a second. At this point, before moving on, check to make sure that you're counting correctly. If not, go back, recount, and make sure you got that correctly. Right now when I look at this, I can see that the carbons are not balanced, the oxygens are not balanced, and the hydrogens are not balanced. I'm going to balance the carbons first, because they're easy. I could just as easily balance the hydrogens first, but I would not balance the oxygens first, because the oxygens are going to be difficult. To balance the carbons, I'm going to change the number of molecules of carbon dioxide to 3, because 3 times 3 gives me 3. Again, that changes my oxygens. Stop the video, pause it, and count your oxygens. You should see that you end up with 7 oxygens. Following the same idea, I'm going to balance the hydrogens by making 4 water molecules. 4 times 2 gives me 8. 4 times 1 gives me 4 oxygens for the water, plus the 6 oxygens that are already on the carbon. That gives me a total of 10 oxygens. If you're not sure how I got 10, go back, stop the video, and recount until you can figure out how I got 10. There's 4 oxygens on the water, plus 3 oxygens on the carbon, so 4 plus 6 is equal to 10. For the finishing it, I'm just going to now take 5 water molecules, because 5 times 2 gives me 10, which balances my whole equation. This is the final one I'm going to show you. This one I'm showing you because there's a mathematical trick that you need to play to balance it. Make your chart, pause the video, make your chart, and when you're done, restart the video so you can see that you did the initial numbers correctly. So those are my initial numbers. If you didn't get that, stop, rewind the video to make sure you get the correct numbers. In this case, I need to change my chlorines, because that is the only thing that's not balanced. The problem is, if I go to this side and I say, okay, what times 2 will give me 3, there's no whole number that allows me to do that. I could do 2/3, but I can't have a partial molecule. That just doesn't work. There's no such thing as a partial magnesium chloride molecule formula unit. So in this case, what I'm going to do is I'm going to actually use some math logic, and since I have chlorine only in one spot in this spot, I have chlorine only in one spot in this spot, I know these two numbers need to be the same. I'm going to use the least common multiple. The least common multiple between 2 and 3 is 6. So my goal in this case is to make this 6, this 6. I have not changed my coefficients yet to do that, but that is my goal of what I want to do. So what times 2 will give me 6? 3. 3 times 2 is 6, but that changes my magnesium to 3. Hopefully that's obvious to you by now. My iron chloride, I need to take 2 times 3 to get 6, but of course that changes my iron to 2. At this point, and this should now be obvious how to balance the equation, pause the video and finish it off before you move on. So I try to use a couple different colors to show you when I'm doing what step. Notice in this case I left the magnesium chloride and the iron chloride in red, because you can see that I did those both at the same time in my head because I needed to use the least common multiple. This is the end of the video. Please remember that when you are balancing